Hello everyone. Today we will going to see some practice questions from the chapter P block elements. This is part 3. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slides and we will going to see some practice questions from question number 19 to question number 27 one by one. Let's start with the question number 19. Among the following, the number of compounds that can react with PCl5 to give POCl3 is. So basically we have given some compounds here in the question: O2, CO2, SO2, H2O, H2SO4 and P4O10. We have to tell that among these compounds, how much or how many number of compounds can react with PCl5 to give the product of POCl3. Okay, so we just react every compound with PCl5 and see that what will be the reaction proceeding and what we will get the product in each case. The options are 1, 2, 3 or 4. So you have 10 seconds to solve this question. After that, we will see the answer. Let's see. The answer is option D, that is 4. If you see at the reactions, PCl5 produces POCl3 with the following reagents. So first of all, let's react it with SO2. So PCl5 plus SO2 giving us POCl3 plus SOCl2. So basically, we just write the reactions in which we are getting POCl3 as a compound because that's the answer. That's the we have to tell the number of compounds, right? So that will be the answer. So we have, you can see here are 4 reactions. So first one is the PCl5 with the SO2, which is giving POCl3 as a product. Second one is in which PCl5 is reacting with water, H2O. So it is also giving us POCl3 as a product plus 2 hydrochloric acid. And in the third reaction, the PCl5 is reacting with H2SO4 and it is also producing POCl3 in the product side. And the last reaction is with P4O10, PCl5 plus P4O10. So it is also producing 10 molecules of POCl3 at the product side. So basically you can see that from the given compounds in the question, we have 4 compounds with which if PCl5 is reacted, it will give us POCl3 as a product. Okay, and this is the question, that number of compounds that can react with PCl5 to give POCl3. So we can see that there are 4 number of compounds like that. So the correct answer is option D, that is 4. Okay, let's move to the next question. Question number 20. When concentrated H2SO4 is heated with P2O5, the acid is converted to. So what we are doing, we are reacting or heating concentrated H2SO4 with P2O5 and we have to tell that acid will convert to which product. Okay, this is the acid if you don't know. So the question is that it will convert to which product. So basically final product will be what? Options are sulfur trioxide, sulfur dioxide, sulfur, or a mixture of sulfur dioxide and sulfur trioxide. So you have 10 seconds to solve this question. After that, we will see the answer. Let's see. The answer is option A, that is sulfur trioxide. So when concentrated H2SO4 is heated with P2O5, the acid is converted into the sulfur trioxide, and this is the reaction following. So basically, two molecules of H2SO4 acid is getting reacted with two molecules of P2O5. It is giving us 2SO3 plus 4 molecules of HPO3, right? So our acid is converted into the sulfur trioxide SO3, and thus the option A is the correct answer, that is sulfur trioxide. Okay, let's move to the next question. Question number 21. The pair in which phosphorus atoms have a formal oxidation state of +3 is. You can see in the options that we have given some pairs of the products or the molecules. We have to tell which in which pair the phosphorus atom have formal oxidation state of plus. Okay. Options are pyrophosphorus and hypophosphoric acids, orthophosphorus and hypophosphoric acids, pyrophosphorus and pyrophosphoric acids, or orthophosphorus and pyrophosphorus. So you have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option D, that is orthophosphorus and pyrophosphorus acid. So, in the case of orthophosphorus acid, having a molecular formula of H3PO4, if you find out the oxidation state of phosphorus in this orthophosphorus acid, so H3PO4, let's suppose the oxidation state of phosphorus is X. So for hydrogen, it will be +1 multiplied by 3 because 3 atoms of hydrogen is present. So 3 plus phosphorus having X oxidation state, so plus X, plus we have three atoms of oxygen. Each oxygen is having -2 oxidation states, so it will be 3 times -2, which is -6, is equals to 0 because our molecule is neutral. There is no charge present on it. And if you solve this equation for the x will come out as +3. Okay. Next product in the pair is pyrophosphorus acid, having a molecular formula of H4P2O5. Now, in this case also, let's suppose we have oxidation state of phosphorus as X. So H4P2O5. For hydrogen, the oxidation state will be +1. We have 4 atoms, so it will be 4 times +1. That means 4 plus 2 times X, because X is the oxidation state of phosphorus. So 4 plus 2 times X, plus we have 5 atoms of oxygen. Each atom is having -2 oxidation state. So it will be 5 times -2, which is -10. Will be equal to 0 because there is no charge present on the molecule. And again, if you solve this equation for the X, 4 plus 2x minus 10 will become equal to 0, and X value is coming out as +3. So you can see that in this option, both the compounds present as pairs, like orthophosphorus and pyrophosphorus acids, having phosphorus in the +3 oxidation state, right? And this is our question, that in which pair phosphorus atom have oxidation state of +3. So D option is the correct answer, containing the pair of orthophosphorus and pyrophosphorus acid, in which in both the molecules phosphorus possessing a +3 oxidation state, right? Thus our D option is the correct answer. Okay, let's move to the next question. Question number 22. White phosphorus on reaction with NaOH gives pH 3 as one of the products. This is a So we have given some, explanation of a reaction, that if you react white phosphorus with the NaOH base, it will give pH 3 as a product along with some other product. Okay. So this is what? This is which type of reaction you can say. So this is the question. Options are diionization reaction, disproportionation reaction, condensation reaction, or precipitation reaction. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is disproportionation reaction. So white phosphorus on reaction with NaOH gives pH 3 as one of the product in disproportionation reaction. This is the reaction following. We have white phosphorus P4 plus 3 molecules of base, that is NaOH, plus 3 molecules of water. On reacting, it gives us 3 molecules of NaH2PO2 and 1 molecule of pH, which is given in the question, right? So you can see this is the example, or this is the type of disproportionation reaction, and that's why option B is the correct answer, that is disproportionation reaction, right? We have asked the type of reaction it is, so it will be disproportionation reaction. Okay. Let's move to the next question, question number 23. The molecule having smallest bond angle is. We have given some molecules in the option. We have to tell in which molecule the bond angle is the smallest. So we have to draw the structures and count the, we have to know the symmetry. We have to know the all the alignments of the bonds. Then we can calculate the bond angle. Okay. So options are NCl3, ASCl3, SbCl3, or PCl3. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option C, that is SbCl3. So nitrogen, phosphorus, osmium, and tin. Okay, these all belong to the group 15, and as it belongs to group 15, so valence electron for all of them is 5, right? Because in the same group, the number of elements having the same number of valence electrons. So MCl3 has sp3 hybridized M element with one lone pair. Okay. Lone pair and bond pair repulsion decreases bond angle. So this is the concept given here, that the lone pair, if present on a metal atom or a atom, the lone pair and bond pair repulsion, it get repulsed, and due to the repulsion the bond angle will decrease. However, the bond pairs of electrons are much farther away from the central atom in SbCl3 than they are in NCl3. Okay, so the bond pairs of electrons in the case of SbCl3, the bond pairs of electrons are much farther away from central atom than if you see in the NCl3. Thus, the lone pair causes even greater distortion in PCl3, ASCl3, and SbCl3, and hence bond angle decreases from NCl3 to the SbCl3. Okay, this is the concept we use here, that the bond pair and lone pair repulsion. Okay, how they get repulsed by each other, and how they get repulsed by the central atom, and how they are situated at a farthest location from the central atom in the different molecules having the same structural formula, like SbCl3, NCl3 having MCl3 as a common formula. M is any metal which is belonging to the, M is any element which is belonging to the 15 group. Okay, so that's the thing, and you can see that it is written that bond angle decreases from NCl3 to SbCl3. That means NCl3 having maximum bond angle to the SbCl3 having minimum bond angle. And thus, the smallest bond angle will be found in SbCl3. Thus, our C option is the correct answer. Okay, let's move to the next question. Question number 24. Which of the following statements is incorrect? We have given some statements in the option. We have to tell which statement is incorrect. Options are: the stability of hydrides increases from NH3 to BiH3 in the group 15 of periodic table. So basically, nitrogen and bismuth both belongs to the group 15, and they both form hydride in the form of MH3. M is the element from group 15. So stability of hydrides increases from NH3 to BiH3. Or nitrogen cannot form d pi p pi bond. Single N bond is weaker than single p p bond. N2O4 has two resonance structure. So you have to find out the incorrect statement among them. You have 10 seconds to solve this question. After that, we will see the answer. See, the correct answer is option A, that is the stability of hydrides increases from NH3 to BiH3 in group 15 of periodic table. This is the statement which is incorrect. Okay. So thermal stability of hydrides decreases as we go down the group in the periodic table. For group 15, that is nitrogen family, because first element in the group 15 is nitrogen. So it is known as nitrogen family. So if you see at the stability, thermal stability of hydrides of nitrogen family, group 15, it is decreasing. Okay, down the group. So the most stable hydride is of NH3, then least stable is of bismuth hydride. Okay, the MH bond energy is in the NH3 391, CH3 322, ASH3 297, SBH3 255, and BH3 is even smaller. Okay, so you can see that we need lesser and lesser energy to break the bond, or we have bond energy lesser and lesser as we go down the group. That's why the stability is decreasing down the group, and thus it cannot be the option A cannot be the correct option. Okay, because in the option it is mentioning that the stability of hydrides increases, but it is decreasing in actual. Okay, that's why it is a incorrect statement. The B statement is due to the absence of d orbital, nitrogen cannot form d pi p pi bond. Thus it is correct, right? Because in the nitrogen there is no d orbital presence. That's why it cannot form d pi p pi bond, because of the absence of d orbital in the nitrogen. And this is our statement for the B option. Also, that is correct statement. Okay. Now, if you look at the C option, the nitrogen-nitrogen bond is weaker than phosphorus-phosphorus bond. You can see the bond energy of nitrogen-nitrogen is 160 kilojoule per mole, and for phosphorus-phosphorus is 209 kilojoule per mole. Right, and it is given that in the C option that nitrogen-nitrogen bond is weaker than phosphorus-phosphorus bond. That means it is the correct statement. In the D option, it is given that N2O4 can form two resonance structures. You can see also there we have two diagrams of resonating structure of N2O4. Basically, we just change the position of oxygen around the two nitrogen bonded, and here we can get the two resonating structure for the N2O4 molecule. That means option D is also a correct statement. So we have asked in the question that which statement is incorrect, which is option A, because option A is the incorrect statement, and thus option A is the correct answer for this question. Okay, now let's move to the question number 25. Which one of following compounds has smallest bond angle in its molecule? Now we have to tell that from the options which molecule has smallest bond angle. Options are OH2, SH2, NH3, or SO2? You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option B, that is SH2. The bond angles in the case of OH2 or H2O is 104 degree. In the H2S, it is 92 degree. In the NH3, it is 107 degree. And in the SO2, it is 109.5. So you can see that the smallest bond angle will be in H2S molecule. And thus, it is our correct option. That is B option. Okay. Let's move to the next question. Question number 26. The number of sulfur-sulfur bonds in sulfur trioxide trimer, formula S3O9 is. You have to tell the number of SS bonds in this molecule. Options are 3, 2, 1 or 0. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option D, that is 0. Basically, if you write the structure of S3O9, it is this. And we have asked the number of SS bond, S single bond, S bond. But you can see that no sulfur is directly attached to the another sulfur. Between the two sulfurs, one oxygen is coming. So that's why there is 0 number of SS bonds present in the structure of sulfur trioxide trimer S3O9. Right? Thus, our D option is the correct answer. Okay, let's move on to the next question. Question number 27. Which of following are peroxoacids of sulfur? We have given options in which we have to tell that which one is the peroxoacid of sulfur. Options are H2SO5 and H2S2O8, H2SO5 and H2S2O7, H2S2O7 and H2S2O8, or H2S2O6 and H2S2O7. You have 10 seconds to solve this question. After that, we will see the answer. Let's see. The correct answer is option A, that is H2SO5 and H2S2O8. You can see this is the structure for the H2SO5, this is the structure for H2S2O8, and they are the peroxoacids of sulfur. Okay, structure of H2SO5, H2S1, O is 5, 2, 2 plus 1, 5, and H2S2O8, S2, H2, and O is 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so they both are the peroxoacids of sulfur, and thus our option A is the correct answer. Thank you.